Okay, in the two previous videos, we talked about radical halogenation of alkanes and alkenes, and now we're going to look at some specific examples. All right, so the first thing we're asked to do is to draw the mechanism for the chlorination of 2-methyl-butane to produce 2-chloro-2-methyl-butane. And then we're told to be sure to include the initiation, propagation, and termination steps. So let's see what our reactants and products look like first. So we've got butane, and then 2-methyl, and then our product is going to be 2-chloro-2-methyl-butane. So the first step is going to be the initiation step. All right, so that's where we're going to start with a chlorine molecule. And we're going to hit that with a photon. And so then we'll get the homolytic bond cleavage. And that'll produce our 2 chlorine radicals. All right, this is followed up by the propagation steps. And so the first of those is going to be the hydrogen abstraction. So we know, because they told us the product is 2-chloro-2-methyl-butane, that we're going to add the chlorine here, but we would have been able to predict that this is the major product, because in this hydrogen abstraction step, we're going to result in, when we pop this hydrogen off, we're going to result in creating a radical. And so creating, in this case, the tertiary radical is more stable than if we were to halogenate here, creating a secondary radical, or here creating a primary radical. So our chlorine radical will come in, right, and it will combine with one of the electrons from the CH bond to form the new HCl bond, and then the other electron from the CH bond will create the radical on that carbon atom. So we've got our new radical, and then the HCl. And then the second propagation step will be the halogen abstraction, so the new radical that we've created. Is going to combine with one of the electrons from the Cl2. The other electron from the Cl2 will create a new chlorine radical. And so now we get our product and another chlorine radical, right? And then we often call radical mechanisms chain reactions, because now this chlorine atom can go on to do the hydrogen abstraction of another molecule and to continue the reaction. Now, I've just shown the 2 propagation steps that we want to happen to get our product, but of course other propagation steps are possible. We could halogenate at other sites on the alkane to give different products, and so oftentimes these halogenation reactions come with unintended side products or unintended byproducts. And so we're just showing the steps, in some sense, that we're hoping to happen. All right, and then finally, they wanted us to show a termination step. And so there are a lot of possible termination steps, and that's just where 2 radical species combine to give a non-radical species. One of those would be if 2 chlorines combine with each other, right? And then that would make Cl2. Or another possible termination step would be if if this radical and this would form our product, but it would also be a termination step because we're not producing any radicals. Okay, in this example, we're just asked to predict the major product of the following reaction. And so, if you remember from one of the previous videos, NBS is an alternate source of bromine atoms, so this is going to be a bromination. And so we need to decide where the bromine is going to add to. And so we're going to have a radical intermediate, and so we want the radical intermediate to be as stable as possible. So we might initially say, oh, well here, this has the most carbons coming off it, but we need a hydrogen to abstract in the first propagation step, so we can't add here, and so our best choice is to add here, which will result in the tertiary radical intermediate. And so the major product would be this, and we're not creating any chiral centers, because this carbon has two methyls coming off, and so this would be our major product. Okay, so this is another example of bromination, We can use NBS or Br2 as our bromine sources, and in this case, we can either have a primary radical intermediate or a secondary radical intermediate, and so I think the secondary would be preferred, but when we add the bromine here, this is going to create a chiral center. And so in that case, because the radical intermediate is trigonal planar, the bromine can attack from either side, and so we'll get both stereoisomers in this case. So we'll get this guy and the enantiomer. Okay, here's another example. And so we have bromination again. And in this case, we can't add here because there are no hydrogens, so our best bet is to add here. And so now when we form the radical intermediate, this will essentially become trigonal planar. So again, I can come in with the bromine from either side. And so two products are possible. We have the bromine coming from the backside, or we can have the bromine coming from the front side. But the mechanism doesn't have anything to do with this carbon atom, so regardless of which side the bromine attacks from, we don't change the configuration of this chiral center. And so in this case, I can have the bromine either on the dash or the bromine on the wedge, but these are not enantiomers, because the configuration at this atom is different between the two molecules, but this one's staying the same. And so in this case, they're not enantiomers, they are diastereomers. Okay, one last example. And so now we have the radical halogenation, and again, this NBS is a source of bromine atoms. And so to predict the major products, we'd expect that forming the radical intermediate here would be the most stable. Not only is it tertiary, even more importantly, that's going to be an allylic radical, and so that's going to be even more stable than just a regular tertiary radical. But if we take a look at what that radical looks like, and remember, when we form this allylic radical, we can have resonance stabilization. And so right, we have these two resonance structures for the radical intermediate, and so the bromine can add either here or here. So we're going to get two products from this reaction. So we can have the bromine adding here, or if it adds to the alternate resonance structure, then we can get the bromine adding here.